name is Francisco Ruiz. I'm associate professor at the Department of Mechanical Materials and Aerospace Engineering here at the Illinois Institute of Technology. I like music, but I don't have any formal instruction. And I started playing the ukulele about 3 years ago after having tried many times to learn the guitar. The Flutino is a musical instrument of the wind family. It's very small, and it works on a different principle from just about every other musical instrument. It works on the same principle as a person whistling, but it optimizes it. So it makes it louder, more controllable, and one arguably could say better sounding as well. You try to optimize the different parameters. So we started with an orifice that was like the inside of a donut, a torus, that has two fundamental dimensions, the diameter and the diameter of the circle that generates the torus. So we were changing both in small increments, fractions of a millimeter, as we were trying to produce the purest sound by doing that, the loudest, most controllable, the widest range possible. We had a total of 4 parameters that we tried to optimize one by one, sometimes combining 2 of them at the same time. Each of them was a different 3D model that had to be tested, slowly converging to the best combination. I went through about 100 different prototypes by 3D printing, which progressively got closer to the optimized shape. We're trying to see if it actually will accelerate music learning in schools.
It's a good fundamental step to people who want to learn a whistle, or just for kids in general music. This would do perfect. Teachers are always looking for different tools, different things that they can do to teach their kids properly. So once you introduce the Flutino, you introduce them to a fundamental pitch that they can start out that's comfortable for all ages. And once you have that developed, then you can start teaching them, okay, now if you want to move to a higher pitch, what do you feel in change?
I just heard from a professional performer, whistler, who I get some of the Flutinos, and he answered back saying that he loves it. He's going to use it.
This is an amazing device. I think it's going to revolutionize whistling for people who can't whistle. It's pretty amazing. One of the cool things about it is that it sounds like my actual whistle.
Right now, all the prototypes are made of 3D printed plastic. But today, in fact, we hope to get one made of 3D printed metal and see how it goes. And I think it could be made of many materials. It could be made of candy, it could be made of pasta, you know. Can you think of a candy that you can actually play music with? This is, we find that finding the sweet spot that produces the sound is very hard. You need to operate within very, very narrow ranges of the values, of the parameters. When you use a spectrum analyzer, it tells you the different components of the sound. So a perfect sound will be just a single line in the spectrum analyzer. So we're aiming for that. It does not need the use of hands at all. You only use your mouth and your breath. It actually works the same way when you're blowing and when you're drawing air. So you don't need to take a breath to stop playing the Flutino. And it never needs tuning, and it never needs batteries. It's easier to control because you're controlling the pitch with the position of your tongue. So you have a continuous control over the pitch. You can get any pitch in between. In a flute or this recorder, the only pitches you can produce are given by the holes. So 6 in this case, or 7 if you consider all open. In this case, though, you can make a continuous variation as you move your tongue, like this. So it's quite a bit more versatile. It allows for more possibilities for a performer.